And bonjour, English. Hello, happy to meet you. Just to introduce myself, I'm coming not from the nuclear, no waste material and so on. I'm coming from the construction site. I worked sometimes in tunneling in construction and in designer, and now with Sika, a construction supplier. And we will talk today about waterproofing of construction sites, of construction elements. So in nuclear facilities, you have the nuclear part where you need waterproofing that is that you can repair, and you have very high demand, and you have additional side elements where other waterproofing systems can be used. So we will talk about the two different waterproofing systems, repairable systems guaranteeing you really a fully watertightness, but also other systems. And also about the durability of the systems. So most of this waterproofing, it's PVC or TPO, it's a sheet membrane that is installed. And the question is, what is the durability of those sheet membranes? So the sheet membrane, the material, aging with the time will lose flexibility, and we say when it reaches a certain level of flexibility means it arrives to an end of life. And as it's a chemical reaction, when you put a chemical reaction in hotter, warmer environment, you can fasten the reaction, because we are talking about 100 years life expectancy. And the thing is, methods were developed to fasten this acceleration by putting the membrane in hot water for about 1 year and seeing how much loss of flexibility these membranes will have about the time. These methods were developed for the large tunnel project through the Alps, like the Telt in France, the Gotthard in Switzerland, or the Brenner in Austria. And the different system used to do this, the different standards and methods to do this accelerated aging, you can find them in some, best is an Austrian guideline that has really all those different systems, where you can see which test method and what should be the result to be proven that the waterproofing system will hold the 100 years. In practice, we have old tunnels, or tunnels that were built in the 70s that had those waterproofing systems. And when there were the big fires in the Mont Blanc, in the Gotthard, new standards asked for new emergency galleries, and those tunnels had to be re-excavated. They were able to gain old membrane that was 40 years in service, and to test those membrane to see how it the behavior was compared to these fasten aging tests. And what was seen is that the effective behavior was much more on the safe side compared to this aging test. So when a waterproofing system is tested and according to those standards for 100 years, you're really sure that in 100 years it will be flexible enough to still be on totally watertight and do its job. This was to talk about the aging, so why we talk about the material that is withstanding 100 years and plus, and now about the system that are used to waterproof. So the classic system is you have a loose laid membrane. This is a 3 millimeter PVC membrane, very flexible, that comes in 2 meter wide strip, and you weld it together. So you melt the material together to connect those elements. And then you install the membrane and you do compartments. These compartments have an advantage, is that with the concrete that you pour on top, you make delimited elements, and in case of water inflow, so you have a membrane that is punched, you will have then water entering the compartment but staying into this compartment, because you have water bars delimitating that are welded to the membrane, that are taken into the concrete, and so the water will stay local. And you have elements that are put in place in the corners, connected with the injection boxes, and you see that you have water coming into this compartment, and then you inject, you put some acrylate, some resin injection, and so you can rebuild the membrane within the compartment and make the whole system watertight again. That's the way to repair. Now you have different degrees. Here you still have some risks that your injection hoses get broken or whatever. So there are systems used when you want to go to more watertight, so the highest level of watertightness. I will come after this to this. So how it's built, this system, compartment system, you have the rock, you have some shotcrete or some element to protect. Then you put a cushion layer, that's a geotextile, just to protect the membrane, that it's not hurt by the shotcrete, that is a rough surface. This is fixed with little discs, little PVC discs, and then comes the membrane, and to hold the membrane, you weld the membrane to those discs. So you melt the two material together, and so you can fix the membrane to this disc. Then you put some water bars that you weld to the membrane. This is to create the compartment. You have those injection hoses, and then comes the concrete. A view in a tunnel, how it looks like. So here you see the welds that were done, and every weld is tested. And you see the little writing on the membrane. This is all the tests that are controlled to prove that every weld is tested and watertight. Then you have here, you see those compartments. You have smaller one, bigger one, but it's always, every element is delimitated. The water bars, here those elements with injection hoses to be sure that the water bars are well injected. Injection sockets, and you have also injection tube, because when you fill up a tunnel like this, you always get a gap in the top where the concrete is not filling, so you have put pipes to inject this gap later on. And where you have to protect the membrane, you put a protection layer. This is to protect the membrane from the inside while you do the construction, so it doesn't get punched before putting the concrete. The other system I was mentioning is called an active control system. That's when you want to go really to the highest level of water tightness, used in some tunnels. So you go with a first layer, a cushion layer to protect the membrane always. Then you have a first layer of membrane that is with large compartments welded together with a second layer of membrane. So between the two membrane, you have like bigger compartments. And then with the inner membrane and the concrete, you create other compartments using water bars, injection hoses. You protect everything with a protection sheet, and then you put the concrete. So the system is that between those two membranes, so you have the two layers of membrane here that are welded together to make a big sheet, and you have welded the two membranes together to have compartments. And in this compartment, you can put a vacuum. You put a vacuum pump, and you can control if the vacuum stays, means that the two membranes are watertight, all the welds are watertight, the system holds. And on job site, they connect this vacuum to a box. And so during the whole construction, you can control that your two membranes are watertight, are not punched. If one guy putting some steel rebars punches the membrane, you will lose the vacuum. It will give you an alarm, and you know you have to repair. So up to the time you put the concrete, you know you have a full waterproofing system that is watertight and also life expectancies of over 100 years. Now you have other systems to use. Those are called fully bonded membrane. It's a membrane layer with a functional layer on top. This is a material on top that will get a bond, first a mechanical and then a chemical bond with the concrete. You can have them put before and then you pour the concrete on it, or you can glue them with special adhesive to the concrete. So pre-applied, post-applied. When we are talking pre-applied is you install the membrane against some formwork and then you pour the concrete against. Or post-applied if you have a construction and you glue it, so you glue it with special cement adhesive to the concrete. And the system is done that water will not penetrate the water. It holds 7 bar water pressure to not circulate between the concrete and the membrane. Some views of projects where it's very easy, easy to applicate, very friendly for a job site, and you get then a full adhesion between the membrane and the concrete, so no water migration in between. Oops. It's not moving. Ça n'avance pas. Ah, voilà. Those systems are all tested for life expectancy to hold. The membrane have tests showing that it holds more than 200 years. The functional layer, so this connection, when you have the membrane, you have the concrete, this functional layer in between that makes the connection. This is also tested for more than 120 years. So you have a system that is really lasting very long. Just to make a little side on, there are also spray-applied membranes. You will, when you get to do with tunnels, are simple spray-applied. You have the rock, the shotcrete. You spray the membrane. It's a EVA material that you spray on the shotcrete, and then you can spray the shotcrete, next layer of shotcrete, the lining on it. Those systems are very easy to use in complex geometries. The only problems, you don't have life expectancy statements for them, and they ask a very dry surface to function. If the surface you apply it on is wet, you will not have a nice curing, and then you will have some water inflow. But it's a system, if you have a lower, like an access galleries, waste deposit, it's a system that could well function. Some picture about those systems where it's applied. So when I compare the different systems, let's say a compartment system where I have the rock, the shotcrete, the build-up that is a bit heavy up to the concrete, the system with a fully bonded membrane against the rock, shotcrete, the membrane and the lining, so it's easier to apply, it's about 3 times faster. And the spray applied also. To see now, we are interested how is it to repair those systems. So if I have a leakage in a compartment system, the compartment will fill with water, I attach a pump and we are reinstalling the membrane. And like this you can repair the leakage. This can be, if you have a 5-meter concrete on your membrane, it functions without problem because you have access with those injection tube to the membrane. Now if I have a leakage in a fully bonded membrane, then the water will stay there because it cannot migrate between the membrane and the concrete. And concrete is normally watertight, so it will stay there. If the concrete has a crack, in this moment, we install a pump and we repair the crack, and so you can install the water tightness. But this goes when you have a layer of concrete of 20, 50 centimeters, not when you have those 55-meter thick concrete layers like in nuclear system, meaning that this will be the repairable system for the very heavy part of the nuclear site. And in the spray applied membrane, again, water will not migrate. And if we have a wet spot, we go and we inject the zone of the membrane to reinstall the water tightness. Another topic is when we go to joints and we want to make joints watertight in between concrete element. So typically you have a water bar, you have some injection hoses to be able to inject the zone, and you put some swellable profile. This is that when you have a leakage in the water bar, the water will enter, it will swell this material, and so you can then, with an injection hose, inject the zone. Those injection hoses you can go and re-inject as often as you want. It's reusable. You see here, you have a central point for the injection, then some protection. So when you put pressure, the injection material goes out. When you stop injection, you clean the hose and you can re-inject after short time or after a few years, whatever. The classic is the water bars that you use. The system for those water bars is the idea that when I have water pressure due to the long way through the water bar, it reduces pressure and it stops the water flow. It's partly quite complicated to make intersection and so on with those water bars. And there are new systems used that are going with the fully bonded system. Here a view of the water bars, classic test. They're all tested for movement joint or whatever. But the system interesting is when we go with those fully bonded water bars, because there you don't work with this long distance about the ribs. You work, the water bar stops the water directly when taken into the concrete. So fully bonded technology, like the membrane, you have the water bar and this contact with the concrete where you have no water moving in between, meaning you just put this water bar slightly into concrete, 2-3 centimeters into the concrete, and this will prevent any water trying to go around, because it's fully adhered to the concrete. Very easy to weld, to movement water bars, to weld together. It's very easy to install. It comes with long rolls, so easy to handle. And a view here how it goes on the job site when you bring it. So you tear this material in place. You weld it together. So welding is just melting the two materials together. Easy to weld. Then you hang this water bar a little bit over the concrete for the concrete placement. And once the concrete is placed, lower the water bar, you push it into the concrete, the fresh concrete, then it will get a full bond with the water bar and totally prevent any water migration and any movement of water around the joint. So nice and easy system, no need to do regresses with the rebars and all this. And it gets full water tightness and also this 100-120 years life expectancy. So this was a little excursus in construction waterproofing, and I thank you. If anyone has questions, we are just in the room next, and you can come with any questions you have.